Okay. Well, we're fortunate to have Engineers Without Borders student chapter back today. And the faculty advisor, many of you know him or have heard him before, Dr. Greg Wilber. He's been a faculty member in the School of Civil and Environmental Engineering for 33 years. And he's been teaching and working in the areas of water quality and treatment. And for the past 13 years, he's also been one of the faculty advisors for this OSU chapter. During that time, the chapter has had projects building um, water filter systems in Honduras, raw water collection systems, and rocket stoves in Guatemala, as well as some smaller local projects. They are currently completing a pipeline project in another village in Guatemala where they traveled this past May. And I'm going to ask Dr. Wilber to come up and introduce three of the leaders in that group. Of course, all of them are engineers. And with him today, he'll introduce those. So, Dr. Greg Wilber, please welcome him.
All right, well, thank you, Larry. We're really happy to be back here again. As was mentioned, we finally got to travel in this past May. For some of you, I know I've talked to you and seen you at other events. You know, from 2020 and 2021, we were not able to travel because of COVID. And then right after that started to ease up, Guatemala got put onto the level 3 travel warning list for the State Department, which made it impossible for a while to get permission to travel. They're still level 3, but the restrictions eased. Anyway, it took a long time, but we were finally able to travel again this past May. So we're excited to have been making great progress on our project, and always happy to come back to you folks. You've always been very supportive of our projects in the past, so we're happy to finally be able to report on some of that progress. So with that, I'm going to turn it over to Trinity Young, who is our current chapter president, and also and Fabian Vega and Kobe McGee, who both were on the trip to Guatemala this past May. So, come on in.
Hello, everyone. I'm Trinity. I'm an industrial engineering student. I'm at OSU. Oh, nice. There's some of us out there. Okay, you guys can come up and join me. Our team is, we're pretty small, but we're growing this year. So we've made it to about 30 students at OSU, and we work on projects that are both abroad and here in Stillwater in the local area. The two that I'm going to talk about mostly today are our international projects, because those deal with water, which I've heard that you guys are most interested in being involved in. But a quick overview of our domestic projects first, so that you know what we do in the local area. We work with the ALS Association of Oklahoma. So that's a neurodegenerative disease that essentially the patients who have it lose all function over the course of the illness. So they're usually confined to wheelchairs by the end of this when they weren't before. So we help go to their homes and survey and tell them kind of what modifications they'll need to make so that they can still live in this home after their disease has progressed. And we've also done some research on devices, so little engineering projects that are more of the mechanical nature and also electrical. We've helped someone set up Wi-Fi and systems so that they can call their wife if they fall. From a really remote location in Oklahoma where they don't have service or any kind of connection. So that's what we've done for this community. We've just got involved in this in the last year, so we're looking forward to growing that partnership. And then we've also worked a lot with Habitat for Humanity in Stillwater. We've helped them build 2 homes that are currently in Stillwater and have people living in them. Very nice families that we met this year. We help do all sorts of manual labor for them, just providing the muscle of young students. And then our international projects, these are much bigger. This is what we spend most of our time doing. They're much more involved. They require a lot of design. And that's where the engineering aspect really comes in. But I'm going to turn it over to, this is Colby, my domestic project lead. We're currently transitioning titles, so He was our domestic project lead last year, and this is Fabian, who was my vice president last year. And they'll talk about the recent trip that we took to Guatemala.
Thank you so much. So my name is Fabian Vega. I am an electrical engineer. Apparently nobody cares about that. Yeah. Yeah. Yeah, no, it's too late. It's too late. So I did become the vice president for this project. I did kind of join little bit at the end. So as they said, this was before the COVID-19 pandemic, and not a lot of visits to Guatemala were capable. So a lot of this was remote sensing over online projects, building, and there are currently 4 people working on this water project. We are the farthest along. During our last summer, we were able to finally talk about connecting our water pipeline to the tankers that are on top of a mountain. And we got to speak to some of the villagers over there in El Rancho. We asked them if they would prefer to have the water running immediately, and they said that we'd rather wait for everyone else to get water before we do. And that was a really important step for them. And that really motivates us to try and work with the other groups who are working with the rest of the water pipelines to get it running. So right here, there's the image of us finally getting the water to run, testing the water quality, making sure that there's no bacteria inside. We also did get to meet with some of the local children over there. We got to talk with a local school, teach them about the importance of water quality and what we want to do to improve it. Try and promote engineering and the importance of water quality, trying to inspire them to join in on whatever studies and improve their education. We asked them if they had any projects that they'd like us to work on, and that they said that they want a computer lab to be constructed for their schools. They currently have computers available right now, but they haven't installed them because they fear that people are going to break in and try to steal them. So our new current project to continue working with this community is to build an entire computer lab with locks, security, all sort of stuff to make sure that the computers don't malfunction due to the weather, and to make sure that nobody breaks in. So
Thank you, Fabian. So I'm Colby McGee. I'm one of our project leads for this. I was also on the El Rancho trip to Guatemala last spring. Not spring, May. Is May in the spring? Yes. Okay, cool. I am mechanical engineering. Yeah, the best one, right, guys? Yeah, this guy knows. Okay. Cool. Okay, so talk about El Rancho. I'm going to talk about more about the community side of what we did down there. So we interacted with the school children and the parents of the school children of the community. The pipeline feeds approximately 300 households. So, the household sizes vary down there. So, standard amount for people, about 1,000 people in the community. We went down there and we talked to the parents of the community and discussed how to treat water, because although they know how to the water that they've been drinking, it's worked for them, it's not necessarily clean, and that's a big part of why this pipeline's there. And we had to talk to them about, although the water you've been drinking is working for you, it's not great, and we have to keep it clean, and we had to do that in a way that didn't patronize them or any way, so we had to keep that going. Oh, God. We also talked to the kids in a way about the same thing, so that the information that we give to the parents can stay in the community and move on to the next generations. And the interaction with the kids was simply just a wonderful experience, because the kids down there are really going to feel the effect of this pipeline. And they loved us being there, and seeing how happy they were was really just a great experience to see, because I'm stumbling a lot. Oh, God. Yeah, you take it.
It was really encouraging to see how excited they all were when they came back. It means that our projects are really paying off. As you can see, they're usually 2 parts. So we have the engineering component, which is the actual pipeline and doing all the fluid pressure calculations and all that boring stuff that's not really that interesting to talk about. But the education aspect is also there, and that makes it much more engaging. We really connect with the community. That's our focus in Engineers Without Borders, and we do it through these projects by providing value, more value to their community through our skill set. So that's why we're continuing our partnership with Guatemala. We've asked them, as you saw, about further projects, and we're going to continue our work there and keep these relationships strong between countries and between students and other kids in other countries. So it's a great experience for engineers at OSU to help broaden our, use our abilities for something that's not just personal and won't just make us money. Along those lines, another thing that we've started this year is another water project in Sierra Leone. This has not been officially approved yet, but we're working with members of a community down there. So we have 2 faculty members who used to work at a university in Sierra Leone, and then one came and worked at OSU, and we connected with him while he was here. And they raised the need that getting water is not the issue anymore. There have been so many different charities that have gone out and drilled wells all over Africa. That's no longer the problem in their community. Their community now needs good water. It doesn't really help if you have wells that are laced with arsenic and cholera and just kill anyone who drinks from them. So that's the big need that he identified as someone who used to live there and has seen these problems. And we decided to respond. We found a really engaged young woman in civil engineering who's working with Dr. Wilber now to create prototypes before the project has even been officially approved, so they're being very proactive about this. It actually follows a project that we did before in Honduras with biosand filtration. So there's a picture of one of those on the slides if you want to look at that. The problem with these, as you can see, is a giant concrete block. So we're working with Sierra Leone to figure out what they need, and they need something that's portable for people who work in fields and away from their homes. So they're modifying this right now, Dr. Wilber and Chelsea Kucher. They're working on getting a prototype ready. So that's the exciting work that we've been doing this year, is getting a completely new device that there hasn't been very much research done on. We haven't been able to find very much literature on the topic. And they'll be prototyping for that this year, while we're also constructing or making plans to construct another schoolroom down in Guatemala, and also we're working on our domestic projects. So our club has become very big this year. We're able to focus on so many more projects thanks to the contributions of our donors and also our students who have really given a lot of time to this, like Colby and Fabian, giving up a couple weeks to travel to Guatemala instead of taking internships in the summer. So we're really grateful for you guys' support that make these projects possible. You can see it as having your own connection, I guess, to these communities in Central America and Africa that need the help and are really excited to continue working with us. So that's what we have for today. Are there any questions about our projects and students that I could answer? Yeah.
Talk about installing pipelines. How far along are those pipelines?
Do you guys want to answer?
Yeah, I got it. There are 4 pipelines that run about 2 miles in total length. They are each divided up amongst 4 different clubs or organizations. They originally were all student organizations. We took on one of them. A team in North Dakota State University, one in San Antonio, took on the other 2. And then another one was dropped but picked up by a professional chapter in Chicagoland. Those other 3 pipelines are kind of all over the place. One of them is just starting. The other 2 are, one's about the midway. The other one's also about finishing. A portion of the pipeline is actually complete. Well, mostly complete. 3/4 of it is built at the start of the summer. 1/4 is still under construction, but everything is fully funded. And that's it.
Those areas when you do a pipeline, you just run them wherever you want to, but you have to have easements.
Easements?
I'm curious.
Did you say easements?
You need an easement to run it, or do you just run them wherever you want to?
Yeah, go ahead.
So they do have to get permissions. A lot of the tank that our pipeline is connected to is most of it is private ranch land, and so they did have to the local EWB chapter had to make arrangements with the landowner to get, it's not like an easement like officially, but they do get permission. Most of the land that it's run over is private ranch land, and that they do have to get permissions to run the pipeline through. And that from what, and we weren't really involved in that, but from what I understand, they were pretty amenable to it. That part was not the complicated part. There was a lot of for the engineers in the room. That was pretty complicated. That we have a hill. It drops pretty sharply, and then it comes back up again, and then goes down again. And so we had to manage the hydraulic head going through that entire pipeline so that it's never too high at any place or ever too low at any place. It was actually a pretty interesting technical challenge. But in addition to the things like the easements and the right of way to putting the pipeline, we're not really involved in that. But the local organization took care of all that.
Any other questions? Yes, Dr. Levy.
Okay, so I think some of us, myself included, may have forgotten because you've described this project before. Could you go through the source of the water and at the end of the 2 miles or so that you indicated of pipeline, is there then a distribution center from there into the various homes, or do people have to come to one place to pick up their water and carry it? And also I'd be interested in, there's a multi-part to this question. What is the material that you use for the pipeline?
Okay. Material is just standard PVC piping down the way.
On the surface?
A few inches below the surface.
Oh, you did?
We did bury it. Yes. So the start of the pipeline. Sorry, I forgot how to talk today. Apparently, the start of the pipeline is just a big concrete tank up at the top of a mountain where a well was already pre-dug. So we put a pump up there, tapped into the well, put it into a tank, and then from there we have one big pipeline essentially going down to partially down the mountain, and then it splits off into 4 lines. And the initial plan was to have it meet somewhere, or have each line, all lines specifically, go somewhere into the town center where people would come and get the water. But that plan actually changed, so where now it's distributed to individual houses. So each family should have their own tap.
So is that part of your project, is to run those distribution lines to the individual homes?
Yes, that's partially already under construction.
Larry asked most of my question, but the pipeline you said is below ground?
A few inches, yes.
Is there maintenance required after it's initially set up? I mean, you have problems with gophers digging in holes or
Yeah,
land shifts and
there's
break?
always going to be maintenance and restoration work, but we usually build that into part of our plan. So EWB likes us to we do the implementation, so we go out and build, and that's what their trip was for this spring. But then we're also required to take a couple years later, or more than 1 year later, we take a post-implementation trip, which is to make sure that they are using the maintenance plan that we gave them in our education of the village, and that everything's running smoothly, and then to fix any issues. So our focus is really on making sure that these solutions last and aren't just one-time intrusions into their life, and then we leave and just have them deal with the consequences. So we do have maintenance built in to the plan, but we've left that for them mostly to do and just us to monitor a couple years later.
Is the water treated in any way so it's drinkable, or is it just to be used for external use like watering?
No,
things?
there is the tank at the top of the hill, like I said, was that the tank and the pump that's pumping it up was put in by a separate another NGO a few years ago. It does have a chlorination system. It's groundwater, so it doesn't really need a lot of treatment, but there is a chlorination system. We did check it when we were there. It wasn't running yet because again the pipeline's not running, but we saw it and we saw the plan that they have. When we do go back for a post-implementation trip like Trinity mentioned, we'll monitor that to make sure that it's dosing it with the chlorine that it needs. But the plan is that it will be treated and be absolutely potable coming from the tank.
Oh, okay.
What is the source of water the community is using now before they will get this from the pipeline?
When we went over there, we specifically asked them of how they got their water. A lot of them said that they have to buy bottled water and use that as their form of drinking water. They also do have some sort of cooler type thing where they just like fill it up with water and have to make sure to cover it to make sure that no bugs, no birds get into it. So currently, they do have some form of drinking water. It's very expensive. It's very bad for the environment because it produces a lot of garbage, and they have no way of actually getting rid of it properly. So this is a way to help them in more ways than one.
When we went down there, how we got our water was through bottled water the same way they did. And just the 9 of us for 5 days in Guatemala, we went through a lot of bottled water. And so cutting just us going through that much, which I don't have the numbers on it, but it was a lot. Probably like 15 containers or like packages of, 24 water bottles. Just us going through 15 in 5 days. You imagine how much the entire community uses every year. I think this pipeline really cuts down on waste for them.
You mentioned arsenic contaminated water. What's the source? What's the source of arsenic? And what are the other primary contaminants that you have to deal with other than microbial?
I'd say so. In Sierra Leone, that's where the main problems with water quality are. That's less arsenic, actually. There's little bits, but mostly the problem is E. coli and cholera. And that's because they all use pit latrines. Nobody has any plumbing or any real sewer system. So they dig their wells, and then they dig pit latrines in very similar areas. And the contaminants from the fecal matter gets into the drinking water, and then everyone's sick. And there's no real way to avoid that because all of their water is mostly from the ground.
So you're saying the arsenic is not really a problem?
It's not as big a problem as cholera.
It is naturally occurring. There are groundwater deposits in Africa and other places in the world where arsenic just naturally is fairly high.
Oh, never mind. He's done.
Any other questions? Anything from this side? We've kind of ignored you.
All the engineers over there, I don't understand that.
Nah, they got it. They already know.
So let's thank them first of all. Just hold on to that. So Stillwater Frontier Rotary